Picture your electricity bill. Not last month's. I mean the one from August. The one that made you stop and read it twice. Then look at your roof. Then look back at the bill. Now picture a dark blue panel, flat against the shingles, pointed at the sky. The promise was simple. Put that thing up there, let the sun do the work, watch the savings roll in. For 20 years, that was the pitch. The same panel, the same angle, the same limitations. Just bigger, cheaper silicon. But something has quietly shifted. Not in the labs. Not in some prototype that will be available in 2030. On rooftops and backyards right now. Systems that don't just generate electricity. Systems that cool themselves. Systems that move. Systems that replace your roof and your power bill in a single installation. Systems that plug into the wall and bypass the entire permit process. Today we're going through 5 of them, one by one. And by the end of this, you're going to look at that flat rectangle on your neighbor's roof and wonder why anyone is still settling for it. If you've been watching your electricity bills climb and wondering whether solar is actually worth it, or whether you even have the right kind of roof, or whether you're just too late to the party, this video is made for you. Stick with it. We're covering all 5 back to back, and some of these you almost certainly haven't seen before. Subscribe if you want more content like this, and let's get into it. Here's something that most people in the solar industry don't lead with. Standard photovoltaic panels hate heat. Not warm. Not mildly elevated. Heat. Real summer heat. The kind that shimmers off a dark asphalt roof at 2 in the afternoon in Phoenix or Dallas or Tucson. On a day like that, your roof surface can hit 150 degrees Fahrenheit. Right at the exact moment the sun is pouring down its maximum energy, your solar panels are performing at some of their worst. There's a term for this, the thermal coefficient. For every degree a standard silicon panel climbs above 77 degrees Fahrenheit, it loses a measurable slice of its ability to convert light into electricity. In the dead of summer, that loss isn't theoretical. It's real, and it's significant. Meanwhile, inside the house, your water heater is pulling gas or grid electricity every single morning. Showers, dishwashers, laundry. The hot water demand in an average American home is constant and surprisingly expensive. These two problems have always sat side by side, never connected. A UK company called Naked Energy decided to build one product that attacks both. The Ver2 system is what engineers call a PVT panel. Photovoltaic thermal. The concept isn't new. Early attempts at PVT were clumsy, heavy, and inefficient. The Ver2 is none of those things. Instead of a flat glass rectangle, the Ver2 looks like something off a spacecraft. A row of cylindrical borosilicate glass tubes, each one housing a high-efficiency monocrystalline solar cell at its core. The key is what's inside those tubes. Nothing. A vacuum. No air molecules to transfer heat away from the cell. Which means the tube acts like a thermos around the silicon. Here's where it gets clever. As the solar cell generates electricity, it produces heat as a byproduct. Normally, that heat bleeds out into the panel surface and starts dragging efficiency down. In the Ver2, that heat has nowhere to go except into a precision glycol channel running directly beneath the cell. That liquid strips the heat away from the silicon constantly. The cell stays cool. The electricity output stays high. And the heated glycol? It gets pumped directly into your home's hot water cylinder. The system can raise water temperatures up to 175 degrees Fahrenheit. Zero carbon hot water, generated as a side effect of keeping your solar panel cool. Think about what that means for roof math. Standard residential rooftops are small. Every square foot dedicated to a solar panel is a square foot you can't use for a solar thermal collector. The Ver2 delivers both from the same footprint. One installation. 2 utility bills slashed simultaneously. The upfront hardware cost sits higher than standard panels, often between $300 and $400 per tube assembly. But when you factor in that you're also eliminating the cost of a solar thermal water heating system, the payback math changes completely. You're not comparing it to one product. You're comparing it to 2. If you've ever looked into getting solar installed and then had a contractor quote you $30,000 and walked away confused, I want to explain exactly what you were paying for. Because it wasn't the panels. Raw solar panels off a warehouse shelf today cost less than 50 cents per watt. The silicon is practically cheap. The reason a standard home installation runs $30,000 has almost nothing to do with the hardware. It's everything wrapped around it. Industry insiders call them soft costs. When you install a traditional grid-tied solar system, you're paying for a master electrician to tear into your main breaker panel. You're paying city building permit fees. You're paying for a zoning inspection. You're paying for heavy string inverters that need to be precisely configured to safely interact with the utility grid. You're paying contractor markup on every single one of those steps. And after all of that, if the grid goes down during a storm, your panels automatically shut off. They have to. Feeding power back into a down line is a safety hazard, which means you've spent $30,000 on a solar system, and during the most critical moment, a blackout, it goes dark. The EcoFlow Stream Ultra was built to reject every single piece of that model. Physically, it looks like a household appliance. Sleek casing, no industrial bulk. But inside, it houses a lithium iron phosphate battery bank, an MPPT charge controller, and a highly advanced microinverter. All of it miniaturized into one unit. You take standard commercially available solar panels, place them in your backyard, on a ground mount, or on an awning. Plug their standard MC4 cables directly into the back of the EcoFlow unit. No breaker panel access required. No electrician. No permit. Here's the piece that makes people stop and ask if this is real. To deliver power to your home, you don't wire into the breaker. You plug the Stream Ultra into a standard wall outlet, a NEMA 15 or NEMA 20. The unit analyzes the exact alternating current sine wave of your home's existing electrical grid, matches its frequency precisely, and pushes stored solar energy back through that outlet. The electricity flows backward through the circuit, reducing your utility draw in real time. Appliances on that circuit run off the sun, not the grid, without any rewiring, without any permits, without any contractor standing in your living room. And when the grid fails, the Stream Ultra switches to autonomous off-grid mode instantly. Its internal batteries and connected panels keep your refrigerator, your medical equipment, your communications running until the utility comes back up. A base unit starts around $2,000 to $3,000. But because there are zero soft costs attached to it, every dollar you spend goes directly into hardware. No markups. No non-refundable permit fees. No contractor scheduling delays. And it's modular. You can add battery capacity or additional panels at any point as your needs grow. It doesn't solve every problem. It's not going to power your entire home off a single unit. But it proves something important. Establishing a domestic microgrid doesn't require a second mortgage or 3 contractor vans blocking your driveway. Here's a scenario that almost nobody talks about when they're pitching you on solar. Imagine you decide you want panels. You get quotes. You're ready to commit. Then a contractor looks at your roof and says, "You've got 10-year-old shingles. Install panels now, and in 5 to 8 years, when those shingles start failing, you'll have to pay a solar crew to dismantle everything. Pay a roofer to replace the shingles, then pay the solar crew again to reinstall the array." So either you install on an aging roof and accept that double cost scenario later, or you tear off a perfectly functional roof right now, before it needs replacing, just to get a clean slate for the panels. This is what's called the roof replacement trap. It silently destroys the financial return on investment for a huge percentage of homeowners who want solar. And it's baked into the fundamental assumption that a solar panel is an appliance that gets bolted on top of a building material, rather than being the building material itself. GAF Energy built their Timberline system on a completely different philosophy. Solar is not an appliance you attach to a roof. Solar is the roof. Visually, a Timberline installation looks nothing like a standard solar job. You won't see a specialized electrical crew hoisting heavy glass panels onto aluminum rails. You'll see a local roofing crew, the same guys who re-roof houses in your neighborhood every week, using pneumatic nail guns to shoot galvanized nails directly through the top edge of the solar shingle itself. That's not a mistake. The Timberline shingle is the only solar product in the world that carries formal certification as a primary water-shedding roofing material. It's not a panel on top of a roof. It is the roof. The photovoltaic cells are laminated into a durable, flexible architectural shingle that lays completely flush against the roof decking. No gaps for wind to catch. No aluminum frame extending above the roofline. No lag bolts punching holes through your waterproofing. The shingles overlap like standard roofing and snap their electrical connections together in a weatherproof housing as the roofer moves up the slope. Tesla's solar roof introduced the concept of building integrated photovoltaics years ago, and it was a legitimate idea. But it required highly specialized installers, fragile glass tiles, and installation timelines that stretched into weeks. GAF engineered the timberline specifically to be installed by the millions of roofers who already exist in every American city. Same tools, same skills, dramatically faster installation. From a financial standpoint, this is what's called bundled economics. You're not hiring a roofing company and a solar company. You're hiring one crew, one labor rate, one city permit. If your home was already overdue for a new roof, the Timberline system turns a mandatory maintenance expense into a leap forward in energy independence. The math is completely different than it looks on the surface. Let's talk about a hidden energy problem that almost no one addresses when they're thinking about solar: the window. A standard window in a home is, in energy terms, a hole in the wall. In summer, intense solar radiation pours through the glass. The room heats up. The air conditioning cranks to compensate. You're running a compressor, spending money, burning electricity, just to push that solar heat back outside. It arrived through your window, and you're paying to reverse it. Curtains and interior blinds don't really help. By the time you stop the light inside the room, the heat has already crossed the glass and entered the building envelope. You're trapping warm air, not excluding it. What if you could intercept those photons on the exterior before they hit the glass, and instead of blocking them, convert them into electricity? Solar Gaps is a motorized exterior blind system where every horizontal slat is built from high-efficiency monocrystalline solar cells, protected by a weatherproof polymer coating rated for hail and high winds. It mounts on the exterior facade of your windows, outside the glass. But the engineering that makes it genuinely different from every other exterior shade product is the tracking. Standard rooftop panels are static. They're bolted at a compromise angle that catches decent light for a few hours around noon and suboptimal light for the rest of the day. Solar Gaps panels move. Inside the header enclosure, an intelligent control unit uses light sensors and positioning algorithms to continuously tilt all the slats in unison throughout the day. From sunrise to sunset, the cells are always angled toward the sun at as close to 90 degrees as geometry allows. To someone watching from outside, the facade of the building appears to slowly, silently breathe. It's a subtle, constant choreography that translates directly into maximum electricity generation. And here's where Solar Gaps creates what I'd call a double financial case. The first side, thermal shading. By covering the exterior of the glass, Solar Gaps blocks up to 85% of solar heat gain before it can enter the building. Your air conditioning load drops by up to 30%. You're not generating electricity. You're not spending it, either. That reduction alone has a real monetary value. The second side, generation. While the slats are blocking heat, they're also generating electricity. Roughly 10 square feet of Solar Gaps coverage produces between 100 and 150 watt-hours of power per day. That power runs down a hidden wire to an indoor microinverter, plugs into a wall outlet, and feeds your baseline electrical load in real time. Same as the EcoFlow approach. No rewiring. No permits. A full kit typically runs between 2. Everything we've covered so far has addressed a specific, concrete frustration. Heat killing efficiency. Soft costs bloating the price. Roofing logistics trapping homeowners. No roof access blocking renters. Real obstacles with real solutions. But the final innovation on this list addresses something more fundamental. Something that every single standard solar panel on every single rooftop in America shares. The panel doesn't move. The sun does. Every day, rising in the east, arcing overhead, setting in the west. Its angle to the horizon changes not just hour to hour, but season to season. A panel bolted flat to a southward-facing roof at a fixed angle only catches the sun at a true 90-degree angle for a narrow window around midday. For the entire morning and entire afternoon, the light is hitting the glass obliquely. You're leaving energy on the table from sunrise to sunset every single day because the panel can't follow. The smart flower doesn't sit on a roof. It stands in your backyard. And at night, it looks like a sealed steel monolith. Compact, armored, silent. When the sun rises, the machine wakes up. A robotic arm unfolds a large circular array of dark blue solar petals. and then the entire head begins to pivot. Slowly, silently, precisely. It tracks the sun across the sky on two axes, both horizontal and vertical, maintaining a perfect perpendicular angle from the moment light breaks over the horizon until dusk. The result of that constant perpendicularity is not subtle. Compared to a static panel of identical size bolted at a fixed roof angle, the Smart Flower generates up to 40% more electricity. Same silicon, same photons, dramatically different geometry. But the Smart Flower's designers didn't stop at tracking. They addressed the two quiet efficiency killers that nobody talks about: heat and dirt. Standard rooftop panels sit just a few inches above scorching dark asphalt. The radiant heat coming off the roof bakes the underside of the cells. The Smart Flower's petals are suspended in open air. Ambient breeze passes freely behind and between them. Passive air cooling, no liquid coolant system required, keeps the silicon running at peak thermal efficiency even through August. And the dirt problem: dust, pollen, bird droppings, snow. These accumulate on a rooftop panel, and nobody climbs up there to clean them off. The Smart Flower solves it mechanically. Every time the unit folds up at night and unfolds in the morning, a set of brushes mounted on the back of the petals sweep across the face of the glass below them. The panels clean themselves every single day, automatically, with no human intervention. There's also an anemometer built into the unit that monitors local wind speed continuously. If a severe storm rolls in and wind crosses a dangerous threshold, the Smart Flower doesn't wait for you to do anything. It folds itself closed, locking its petals back into the reinforced steel base until the weather passes. Traditional rooftop panels just sit there and take whatever the storm delivers. And here's a dimension of the value proposition that doesn't come up with rooftop solar: portability. If you sell your house, you cannot take your roof panels with you. They're bolted in. They become part of the property transaction. The Smart Flower unbolts from its concrete pad. You fold it up, load it, and take your power plant with you to the next address. The Smart Flower sits at the high end of the residential solar market. This is not a budget product, but its value proposition is built on completely bypassing the agonizing soft cost structure of traditional installations. No roofers accessing your shingles. No structural engineers analyzing your rafters. The unit arrives fully assembled. A technician anchors it to a small concrete pad, connects the integrated inverter, and it's live. The 40% efficiency advantage over static panels compounds every day of every year. Over a decade, that gap in performance is substantial. Combined with the self-cleaning, the passive cooling, the storm protection, and the portability, the Smart Flower makes an argument that the roof was never actually the ideal place to put a solar panel in the first place. So where does that leave us? The flat black rectangle on your neighbor's roof is 20 years old as a concept, and it still works. It's still better than nothing. But the idea that it's the only viable path to energy independence is outdated. If you live somewhere brutally hot, the virtue is harvesting that heat instead of being destroyed by it. If the permitting process killed your solar plans, the Stream Ultra plugs into the wall and bypasses all of it. If your roof is aging and the math never made sense, the Timberline system combines two projects into one. If you're a renter with no roof access, Solar Gaps turns your windows into a generator. And if you want the maximum possible output from a given piece of silicon, the Smart Flower is moving toward the sun every minute it's operational. Whatever was standing between you and solar, there is now a system designed specifically to remove that obstacle. The physics haven't changed. The sun is the same sun. But the engineering available to harvest, it has transformed completely. None of this is magic. None of it is a shortcut. Every single one of these systems works because an engineer sat down and refused to accept that the problems we'd been living with were permanent. Heat was always going to be a problem. Permits were always going to slow things down. Roof logistics were always going to trap homeowners. The sun was always going to move while the panel stayed still. Until someone decided it didn't have to. That's what the best energy technology does. It doesn't just generate power. It removes the excuse that was keeping you from starting. If you want to keep exploring what's possible on the energy independence front, we just published a full deep dive on the 6 most innovative small wind turbines available for residential use right now. I think you'll find some of the same principles showing up in completely different form. Link is right there. And if this video was useful, you know what to do.